Or call for the light.
That's right. No, you're good. You're good.
Welcome to All Space Considered. Yay, welcome everybody. Thank you so much. We come to you live every third Thursday of the month, except when it's not on the third Thursday, but we haven't broken that in a while, which is great. So thank you all for joining us. You can follow us on social media, find us on the web, of course, on the internets. That was really bizarre. Okay, anyway, that backed us up to the end of the show. It shouldn't do that. Anyway, so moving forward, great start to the show, right, Saul? Today is Thursday, December 19th, 2024. We are only a few days away. Saturday is actually the solstice. So the winter solstice, the December solstice, for those in the southern hemisphere, it's going to be summer for you. But it's going to be great. So we're here to celebrate the holiday season a little bit. But tonight, we start with a dramatic reading. So tech crew, if we can lower the lights, and we hope you enjoy this brief interlude.
May not the worlds, notwithstanding this great resemblance between them, differ in 1,000 other things? For though they may be alike in one particular, they may differ infinitely in others.
It is certainly true, but the difficulty is to know wherein they differ. One vortex has many planets that turn around its sun. Another has but a few. In one vortex, there are inferior planets, which turn about those that are greater. In another, perhaps, there are no inferior planets. Here, all the planets go around their sun, beyond which is a great void space, which reaches to the neighboring vortices. In another place, the planets take their course towards the outside of their vortex and leave the middle void. There may be some also quite void, without any planets at all. Others may have their sun not exactly in their center. In short, what variety can you wish for? But I think I have said enough for a woman that was never out of her own vortex.
I submit and beg your pardon. You quite confound me with worlds and vortexes.
Oh, sir, vortices.
Oh, yes.
I've a great deal more to tell ye. You see that whiteness in the sky, which some call the Milky Way?
Mm-hmm.
Can you imagine what that is? Mm-mm. 'Tis nothing but an infinity of small stars, not to be seen by our eyes, because they are so very little, and they are sewn so thick, one by another, that they seem to be one continued whiteness. I wish you had a long glass to see this anthill of stars and this cluster of worlds, if I may so call them.
All right, well, thank you so much for that. Thank you, Bill. And he'll pass along a microphone. Wonderful, wonderful read, Bill. Our Bill Gruneberg, everybody, and Laura May.
Yeah,
now,
wonderful.
You might be wondering, what was that I just saw? Well, this is what the read was from. And Laura May, why don't you tell us what this is about and how you discovered it?
So this is actually a text from the 1600s, the late 1600s, believe it or not.
86, I think.
Yes, correct. By a man called Bernard Le Boyer de Fontenelle. I don't know how you pronounce that. Barnard de Fontenelle, who was a playwright and a scientist. And he was actually the very first, more or less, modern science communicator who wrote, not in Latin, but in the plain language, to disseminate the ideas, especially the ideas of heliocentrism. And so it's pretty remarkable that his text actually predicted quite a lot about exoplanets. He even predicted transits, which we'll talk about more a little later. migration, planetary migration, the differences in different planetary systems.
Moons. That was the minor worlds, or the minor planets, were the moons around other ones.
So pretty remarkable text if you think about it at the time.
That's a conversation that could have happened recently. But he's talking all these other systems with worlds going around them. Worlds, if I may call them. It's amazing to me. We're at the end of 400 years of people who are having these conversations, and we're the first generation that can
actually say we found them.
I mean, wow, that's a long period of frustration for people.
It really is. And people looked. People didn't not look. They thought of ways to try and find those exo-worlds, exoplanets. And we're going to talk about some of those ways to find them tonight. We're also going to talk about some of the most recent findings in exoplanets. But let me talk about the show just a little bit, get us back on track here, although I felt like we were on a great track there. It is All Space Considered, like I said, which is brought to you by Griffith Observatory. And Griffith Observatory is owned and operated by the City of Los Angeles and the Department of Recreation and Parks. And we always like to thank Griffith Observatory Foundation as well. They are our exclusive nonprofit partner. And thanks to all the members and all the help they provide to Griffith Observatory. So it's always wonderful. And thanks to all of you for joining us tonight. And tonight we got a great show. We do have our usual astronomy news bulletin, and it's going to blend a little bit into our feature. We have a story about Venus Gal found in SoCal. All right, what is that about? I think we went a little crazy on these titles, but it's great stuff. Hot goss from Io. Does anybody even know what that means? I'm not sure. I think so, but the kids out there...
I thought it was gas.
Yeah, the kids out there are roaring with laughter, I think. Feel the Burn, Barnard star, new planet. Mapping the exo-Neptunian landscape. Although that story, I dropped it. It was a mess. So that one's
next episode.
Next episode.
I was going to say that's
it was too long, too confusing, and anyway, and I wanted to get to that. We keep losing what's going to be up there. I don't know what they're doing.
I got to say that's going to be the name of my post-rock band.
I was going to say that's
so it's pretty good. Pretty good name.
Anyway, and then we have TRAPPIST-1 and the 3-body problem. Although there's more than the 3-body, it's the 7-8-body problem, and there might even be more. Roman was not built in a day. What's that all about? We have Jared giving us an out to launch tonight, which will be pretty great. We have a few launches to talk about. And then exoplanets. Well, you noticed a lot of these stories are about exoplanets already, but we have more. We're doing a deeper dive. And then lastly, a Goodnight ASC. So we'll say goodnight to everybody. And then folks that are here live in the theater at Griffith Observatory, we have a special treat for you. So after we end the show and after we run the credits, stay, and we have a special video for only you. We don't want to get sued, so we're only going to show it in the theater. Stream, email me, or tweet at us. No, we don't even follow it anymore. On Instagram, message us and ask what the last video is. We'll tell you. So, all right. So you might be wondering, what is this beautiful picture? Well, this was made by our very own Ella Ritz, one of our artists on staff, and she grabbed an exoplanet image in the background that was put together a lot of the Kepler and TESS and some of the programs that have found a plethora of exoplanets, and these are artistic renderings of what we think these worlds might look like. And in fact, we will return to this. Chris, you've made a lot of images about worlds.
A few.
And
we're trying to catch up, brother.
Yeah, indeed. And we're going to show some of those tonight and talk about them. But first, we're going to take a little detour into the world of asteroids.
That's right. So you may be wondering what this image is. I hope you guys have your glasses on so you can see the little. Oh, in fact, I guess it's not. It's not on a loop. But,
no, but
in this image is a fantastic and very unique asteroid. It is called Alochaxnum, and we actually have the person in the audience tonight who discovered it. Bryce Bolin is here, who discovered it with Frank Massey. So it was actually discovered in Southern California at Palomar Observatory, and it is particular in that it is the first and only inner Venus asteroid. So what this means, you may be familiar with asteroids that are in this big asteroid belt that we have between Mars and Jupiter, but there are actually asteroids that are inside the orbit of Earth, and in fact we think there are populations of them closer to the Sun. So this one goes inside the orbit of Venus, which is pretty remarkable. So
By
right
the way,
here.
Did Bryce take a wave?
Yeah, I was going to say.
Where is Bryce?
Where is Bryce?
Is Bryce being discreet somewhere? Bryce is hidden
There he is.
over
I would just want, yeah.
Congratulations.
Anytime we have the
Congrats,
asteroids, thank you.
Bryce.
Yeah, congratulations.
Great stuff.
That's so cool.
Thank you
Very
for
good.
bringing us amazing content. So
Yeah,
this is also an image of it that was shot with a background galaxy. Kind of looks like a supernova, right?
Yeah, it really
A little
does.
bit.
In fact, when I was
But
on
it
observing
moves.
runs and I would have galaxies, I'd always look and be like, what's that bright spot? And I'd go look at a different epic image. And well, if it moves, you're like, well, it's an asteroid in the way. But I would never think to be like, well, is that a one near Venus? Is
Yeah.
that, inside Venus as well?
And they're very difficult to find, right? Part of the difficulty is that they can be caught in the glare of the sun, and you don't really want to aim most telescopes at the sun. So this is something that Bryce and other people are trying to figure out. And so this is a potential, so this is the various populations. These are just the names, so you can see of the different populations of asteroids that are inside our orbit. They're also technically NEAs, near-Earth asteroids. So the Amors, the Apollos, the Attens, the Atiras, Alos, and potentially there could be a family of the Vulcanoids. And those are inside the orbit of Mercury. Very, very difficult to find. We haven't found any yet. Maybe at some point. And in
Get
case,
on it, Bryce.
Yeah, please. Hurry up. And in case you were wondering, so this is to show its orbit. So here it's named 2020 AV2. And so it's just to show how its orbit appears inside the orbit. Here's another view of it where it is called Alochaxnum. And you may be wondering why this name Alochaxnum, right? What does this represent or what does it mean? And so this was actually, it was named under Bryce's initiative by the Palma Band indigenous people of Southern California. And so this is their native Luiseño language, and it means Venus girl. And they originally wanted to name it Venus's daughter, but that was too long for the International Astronomical Union to accept it in their language, so it ended up being called Alochaxnum for Venus girl.
Venus girl.
Yeah,
Yeah.
which is very nice.
Very cool.
So
here's our hot goss from Io story. And Jupiter has had one of our spacecrafts there. The Juno spacecraft has been orbiting. It was sent there to study the insides of Jupiter. It had a camera on board that brought us wonderful images. People got to play with them, get all sorts of crazy stretches on the colors and bring out all sorts of great details. But recently, fairly recently, it flew by the volcanic world Io, which is the closest moon to Jupiter, the closest large moon. So it's tidally stressed, which keeps it molten essentially, and it's the most volcanically active moon, in fact body in the solar system that we know about. There may be others, but Venus might be more active. Venus is crazy. But that's an actual eruption coming off the surface of Io there. And you can see how it compares in size. Ganymede's roughly moon-sized. It's a little bigger than our moon. But Io, a little smaller than our moon. And when the spacecraft flew by, it took a lot of measurements, and it measured the gravity and how the gravity changed. And it was able to piece together where it was molten underneath. And the question was there an entire sea that was molten? Was it a molten all underneath, or was it little patches and patchy? Well, let's take a look at this video that they put together. Come on, go forward. Of course, I have it clicked to play.
there we go.
Here we go. I'm going to have to remember. So you can see some of these are artist renderings. They put together the actual images and then stitched them into an animation. So this is the sort of thing where you can paint real images that were taken onto a sphere and then fly around it. So that's a combination of artistic work and real renderings. And now we're into pure artwork, of course. It did not fly this close, but this is the sort of lava lakes that appear on Io. There are massive lava lakes that are seen and eruptions that have been going on for decades. When Voyager flew by, it saw the same volcanoes that then Galileo spacecraft saw that then now Juno is seeing. They're in the same places. So that tells us that, well, they're probably the sources for these volcanoes have got to be pretty long-lived. They're not short-lived because they keep pumping out more and more. And then the gravity told them the sources were also localized. It was not a moon-wide sea underneath, that it was smaller, looking more like this. So if we take a look at it, you can see the patchy lava sources. Exactly. Now they made the core red in the middle and then dark. It was uncertain whether the core was molten or not. the measurements were consistent with both. They could make it fit both a solid core or a molten core. So they made it a little of both there. It's a chewy nougat center in this thing.
Forbidden Kinder Egg.
Yes.
Yeah. So a very neat result for a spacecraft that was set to go study Jupiter's interior to learn about the interior of this moon. Now this also can tell us about tidally stretched exoplanets. But exoplanets that are so close to their star, they're being squished too. These sort of processes may be happening on them as well. So this is a good way for us to use our solar system to learn about other things that are out there. So Barnard's star is the closest star, well, not closest star, it's the closest single star to our own. Alpha Centauri system is a triple star system. Well, Barnard's is just a single one, and it moves across the sky very quickly, by the way. And you can see there it is labeled. There it is in the sky. What constellation is that in? Does anybody know?
Ophiuchus.
It's in Ophiuchus.
Yeah.
Should be.
Do we have any Ophiuchians in the audience?
I think, in fact, Ophiuchus season ended yesterday.
Did it end
Yeah,
yesterday?
I was going to say,
right.
it's brief, but yeah.
It is brief. What we're speaking about is that the sun goes through the zodiac constellations, and most people are familiar with the 12 major ones, but there is a 13th that the sun passes through, and it does this in early December, and it passes through Ophiuchus, so it's fun that we have a story about a star in Ophiuchus. But Barnard's star moves very quickly through the sky. It's the fastest moving star with its apparent shift, so a proper motion it's called in the sky. But we just learned that it also has a planet. There it is, kind of distance from the sun. The Alpha Centauri system is a little closer in terms of its actual distance, still very close. Here you can see it. There you can see it moving. It's there, it's not there, so it had moved from somewhere. I don't see the previous spot in the image, so I don't know.
There it isn't.
There it isn't. Anyway, they were using the telescopes to actually measure the radial velocity method, how much the star was wobbling due to the presence of a planet. So they used a very, very accurate spectrograph to do this. And sure enough, there's a planet. It's bigger than Earth, but it's there. It probably is not habitable. It's too hot. But a cool finding that the single star nearest to us does have a planet. We're finding them on just about every star we look at, which is crazy.
This was one of the very first stars they thought might have a planet. There were rumors that went around for years and years and years.
Yep.
When I was a young thing, you know, in the 1970s, and all, you'd hear, does Barnard's have a planet or not? Even back in the 1940s, they were looking, and they would put out a claim, and they would be retracted. No, the data's not right. So I'm very excited, but I don't want Lucy to pull the football back again.
Yeah.
We got a Barnard's planet. I don't want to lose this one.
Yeah, even in 2018, I think there was an announcement about one that was based on more modern data, and it fell apart too.
Yep.
Another system that has planets and around also a red star is the TRAPPIST-1 system. And this is a beautiful artistic rendering.
Yeah, it's a beautiful image by a French artist called Manchu, who gave us, very kind to give us these images to use of this system that he made of TRAPPIST-1. And it's a little similar to when we see these kind of planetary alignments. Sometimes you might see them in the news. They get announced and people go out and observe them. And so this is what it would look like from the surface of one of these planets.
And each time those alignments happen, the world comes to an end.
Yeah, that's right.
Just over and over again.
That's what all the local newspapers claim.
Right.
Yeah,
That's
the
right.
local
Right.
paper.
I was going to say, a friend of mine, Dr. Mike Lund, astrophysicist, he writes a like parody paper and publishes it every April 1st. And one year he did about lycanthropy, the TRAPPIST-1 system, or basically werewolves at the TRAPPIST-1 system. How would you deal with it with 6 moons in the sky at the same time?
Yeah.
So
Full moon,
be a real
full
pain,
moon,
I'll
full
tell you
moon.
that. So
It would be. Now, what we're talking about here is 1, 2, 3, 4, 5, 6, 7. There's 7 of them, the 7 dwarfs. But they're all close to Earth-sized. Some are a little bigger, some are a little smaller, but they're relatively Earth-sized. They're orbiting a faint red star, so they have to be pretty close to have liquid water. Now, scientists cleverly name them TRAPPIST-1, B, C, D, E, F, G, H. A is the star, so, you know. Now, some of these are actually within what we call the habitable zone, where liquid water could be on the surface. So B, C, D, we think those are cooked. They're probably charred. And then E, F, and G, maybe they do. But you'll find different papers in the journals. Yeah. Some will say E is still too hot, F is okay, G is frozen. So it depends on who's writing the paper and what their assumptions are, but it's all over the place. But it was pretty well accepted that the closest exoplanet to the star would be charred, that it would be fried. Well, along comes the James Webb Space Telescope with some measurements of the inner ones, and it's actually seeing the light coming from these exoplanets. It's both bouncing off from the star and the emissivity. They're glowing in the infrared. Well, planet B, it's probably a rocky, jumbled up surface that has plate tectonics and weathering, which surprised them. They thought it would be completely smooth and like paved over by volcanism, a lot of lava flows. And instead they're seeing like probably mountains, things that have to have tectonics on it. So it's the surface is too jumbled up, it's too rough. The signature of a rough surface is there. Or a very thick carbon dioxide atmosphere.
Right.
An atmosphere, a thick carbon dioxide atmosphere right next to the star? What? No, how? They did admit, no, it's probably not true. This is not likely. They didn't believe it, but they can't rule it out. So maybe these inner ones still can have an atmosphere. There was another modeling paper that said these rocky planets around these red dwarfs could survive their massive flares and still have atmospheres. So maybe. Now this makes astronomers really interested to say, well, these habitable zones, maybe there's aliens there. Maybe they're living there. Could they be? How could we find them? Well, if the planets line up like this, and they're talking to each other with radio waves, let's say there's aliens on a couple of those, and they're beaming radio signals back and forth, you know, their comedies or whatever it may be, or information. Well, if they line up and you're off in the distance, so pretend you're looking at this image and those planets line up, well, you have a chance to eavesdrop on it. You point your radio dish at it and listen and say, do we hear the aliens? And you can kind of see, here's a little plot of them lining up. A bunch of them line up at various times. And you can see how that happens. Dash lines will appear. It's not that exciting. And then the radio waves, and then you can they're talking back and forth. Well, we tried to listen. They used the Allen array up in Northern California, the SETI Institute, which is searching for extraterrestrial intelligence.
I'm betting the answer is no.
Well, they picked up a bunch of signals. Thousands of them.
It's what we've been hiding.
I was going to say,
thousands of them.
This is quite a story to
all
put
of
as your
them-
fourth story.
All of them. We
were
buried the lead.
That's
No,
right.
all of them turned out to be false. However, they didn't expect to hear any signals. If the aliens that we don't know about yet, so don't quote me on this, if there were aliens in this system using technology like we use, this wouldn't have picked it up. It would have been too faint. But they're building a bigger array. Not in California. This is in South Africa. It's called the Square Kilometer Array. And indeed, it'll have the collecting area of a square kilometer, which is huge. So this will be the largest collecting area for a radio telescope. It'll collect in some different bands. But this one will be able to pick up radio signals if the TRAPPIST system is talking to each other using radio signals like we use. So our technology is getting there to be able to do some real work. So don't give up on SETI just yet. They're still working on it.
Yeah. Maybe one day we'll hear Freebird coming from
Maybe. Maybe it'll
planets
be
yelling at them.
Now, there are other telescopes coming online as well soon. The Nancy Grace Roman Space Telescope is about the size of Hubble. 2.4 meter mirror. In fact, it's basically the same kind of mirror that Hubble had, but it does have different instrumentation on board. It is in a long line of telescopes, as you see here, space telescopes, and W First was renamed for Nancy Grace Roman. She was the first NASA chief of astronomy, and she's generally credited as being one of the people that made Hubble happen. She was instrumental in making it come about and giving us a space telescope. So naming this telescope after her is a wonderful honor for her, as it should be. Now, the difference between the two is really the field of view. They're using the field of view to get a much wider picture. So you can see Hubble, that little square down there at the bottom of the frame, that's how much sky you could capture at once. Webb, you can capture a little bit more, and then Roman, it's this huge area, that strange shape is what we'll be able to capture. In the background, by the way, that's the Andromeda Galaxy. That's about 2 full moons across, give or take. So the Roman telescope will be able to more or less fit the moon in it, which is an astounding field of view. It is huge. It'll be able to find exoplanets. You can see there's the field of view. The sort of nebulae it'll be able to get in a single shot. It'll be absolutely outstanding. And it will increase our ability to find exoplanets. The Roman telescope is that blue pencil beam. It can shoot all the way to the galactic center. Kepler, a space telescope we'll talk about some of the findings from it later, had a pencil beam off in that green direction. And then the TESS mission is that red sphere around us. It doesn't go very far, but they're looking at a lot of faint stars in every direction. So they sort of looked in every direction rather than in narrow directions. So how do they do it? Well, the Nancy Grace Roman's going to use a coronagraph. It's going to block out the light from the star and actually be able to see the exoplanets. That's a real image of exoplanets off to the right there. That's the Gemini planet imager, I believe, that was done here from the ground. But using similar technologies with a coronagraph where you block out the starlight, you can actually see exoplanets. They're expecting to pick up thousands of them using Nancy Grace Roman. We're talking about this because the spacecraft's being put together, and this instrument was loaded onto it.
Yeah, and one of my favorite things about the Nancy Grace Roman telescope is that actually this all began back in 2012 when the National Reconnaissance Office, which is the spy satellite division of the United States Space Force, basically went to NASA and said, hey, we have 2 obsolete optical assemblies with mirrors. Would you like them?
Yeah.
And NASA was like,
Yeah.
do you have to use air to breathe? Yes. And this is one of them. But
there was long debate actually over it. And there still is. Some folks.
you're just not allowed to aim it back at the Earth. So
Well, there's that. No, well,
that's what they said. So you can have
anyway,
it. Just don't aim it.
we will be thrilled to have Nancy Grace Roman. Don't get me wrong.
Yes.
But we did say no to the other one. And part of it was the work that goes into turning something that was designed to look at the Earth into something that can look at the sky. It's a lot more work than a lot of people think it is. It's not as simple as just to slap a different filter on there.
Yes.
So this was great for what we could do, but there are other telescopes coming. But yeah, it's a fascinating story. It's a fascinating story. There were some astronomers like, can we say no to both? And I was like, don't do that. Don't do that.
It's a free telescope.
Exactly, free telescope.
Nice pair of binoculars you get out of that deal.
Yeah. So speaking of launch and stuff, Jared, what's been happening up there in Launchview?
Oh, just a few things, and I absolutely adore the fact that you guys put this Saturn V launching Skylab on here. So we got the big shroud on top of it instead of the Apollo capsule that would sit people on top of it. But of course, just to talk about a few launches that happened recently. This one was on October 4th. This is
we have engine ignition 1 and liftoff of the United Launch Alliance.
Are they usually that enthusiastic?
Yeah, it's-
Oh, yeah,
It's like, oh
yeah.
my gosh.
You
Let
get
me
the
tell you.
impression she's happy.
Yeah.
I feel like
So
I'm
this
used to hear
is
more neutral.
United Launch Alliance's Vulcan Centaur. They are developing this in order to compete with SpaceX and also to capture some of the national security launch market. This was its second flight, and it's using engines that were developed by another company called Blue Origin, and it's using solid motors that were developed by Northrop Grumman. And you're going to notice something happen on the solid motor closest to us right now. Oops. Yeah, so what actually ended up happening on this flight, so for those of you not in the rocket business, seeing one plume on the side of your rocket bigger than the other, usually not a good sign. But luckily, what it looks like happened is that the nozzle on the solid rocket booster basically shredded itself. It coughed itself out. And you can see that plume is not particularly well contained. At all.
Yeah.
And when that happens, you lose efficiency. Sometimes you lose your booster entirely.
A solid rocket motor out of control is bad news.
Yeah, they're solids are interesting because you light them and then they don't turn off until they're done. And that's kind of how they work. And they compensated for this. They were able to burn that center stage about 20 seconds longer. The two engines from Blue Origin, the BE-4s on the first stage, were actually able to handle the deviation from what we call asymmetrical thrust. Or basically, the thrust is no longer going through the center, it's off center, and now we have a problem. So it handled it beautifully, which is great to see, because obviously we want as many players as we can get in the launch market. It's just, let's not do that again.
Yeah.
So-
Now, was that nozzle 3D printed or anything, or is it?
No, it wasn't
Well,
3D printed.
They do 3D print some parts for some select rockets. So.
Yeah, I don't believe these are 3D printed. This is a new booster from Northrop Grumman called the GEM 63 XL. So we'll have to see what they do with the upcoming launch, and they should actually be having another Vulcan Centaur launch at some point, February, March. But obviously they are reviewing all of the data to make sure that they don't have this happen again with that. And then we go on to the big one from recent times. For those of you who may have been living under a rock, we'll just remind you about this.
Good grief.
It's just incredible.
Yeah.
That's illegal.
Yeah, we didn't run that in reverse. That's how it went.
Yeah, so that was a Starship Test Flight 5. Oh my gosh, with the booster catch, Will Gerstmeyer, who's at SpaceX now, at a press conference before it said that they're able to get like sub-centimeter precision and landing, and we were all like, whatever, like he's just saying that because it sounds like good PR. And then immediately many of us started writing apology letters at that point once we saw that.
Yeah, they basically caught a Saturn V.
Yeah.
I mean,
Chopsticks.
yeah, with chopsticks.
Doesn't
This
get-
is crazy.
Well, and what gets me is it needs to be rotated the right way too, because
Oh, wow.
there's
Right.
little catch
It-
things
yeah.
that are
Right,
only
of
on
course,
two of the
yeah.
sides.
Yeah, and then also the arms have to coordinate at the correct time too.
Yeah.
And also, if you notice when it's coming down, the arms actually aren't staying away from the rocket as it's coming down. They actually start to grab the rocket as it's still sliding in. So they kind of guide the booster.
That's
And that's
true.
just like,
Yeah, I'm not that
Amazing.
coordinated.
I wish I could comprehend these kinds of things, but even having done this stuff for 15 years, it still blows my mind.
Now they launched another one though.
They sure did, yeah. Flight 6. They did not get it to return to catch. Unfortunately, what it looked like happened was that a communication antenna on top of the launch tower broke as it did this pitch away in order to make sure it was heading out.
Was this from Vandenberg?
This wasn't from Vandenberg. This is from their site out at Starbase in Texas.
Oh, Texas, that's right.
Although they are working on a new launch site at Vandenberg, so we'll see. Hint, hint.
Exclusively for
Nudge, nudge.
SpaceX?
if they
or-
don't catch one of these, they're going to need a new launch landing.
Yeah, I was going to say, with the last flight, with catching the booster, we were either going to see them catch the booster or show us the fastest way to demolish a launch pad. So luckily they caught it. Also with this one, luckily they said, no, we're not going to do the booster catch. We're going to go ahead and do an ocean splashdown. But still, this is 16.5 million pounds of thrust. This is twice a Saturn V. This is 400 feet long from tip to engine.
Yep.
It's huge. It's bigger than a Saturn V, and I gotta go see one of these at some point.
You and me both.
So
So
there's-
it's a good thing that they aborted it, though. It actually shows the rocket, as I understand, can talk to the tower.
Yes.
Back and through the tower.
Yes.
And if anything isn't quite right, it negotiates that last delicate bit of positioning.
Yeah, and actually very early on, just a little bit after staging there, they communicated, no, we're not good.
Right.
We're not
yeah.
good
And
to
if
come
they
back.
didn't have good
So
communication, no, wave off. And that's smart.
Yeah.
Protected their launch pad.
That's exactly what you want to do, and protect the area around your launch pad too,
course.
because there are people living in and around that area. But this is a great view from the booster as it's coming in. I love watching those grid fins, knowing that they're like twice the size of a pickup truck.
Wow.
Yeah.
So they're huge. And then this is it landing out in the ocean, the Gulf of Mexico, just off the coast. A friend of mine, Tim Dodd, everyday astronaut, he's got a great shot that shows it landing in the ocean. And then SpaceX here cuts away from what happens. But essentially, it lands on the ocean, it splashes down, then there's nothing there to really hold it. So it tips over, and then the methane tank ruptures. And if you've ever watched methane tanks rupture before, there's lots of fire involved. So it made big boom. Out there, and I'm talking like a fireball, a couple hundred feet across, a couple hundred feet high. So, but that's the way it goes. As they say, if you're not breaking stuff, you're not testing.
It's like the early days of the space race.
Yeah,
So
exactly.
absolutely.
When is the next one scheduled?
So the next one, we just saw that the FAA drop the license for SpaceX. It is set to be on January 11th.
Okay.
So we'll see how that works out. On this one, they are going to the Block 2 Starship and booster with that there. So they're upgrading them, basically making them bigger and a little more oomph out.
Bigger?
Yes, bigger.
Bigger?
If you can believe it. And then if that
They're going
one-
to launch Texas next time?
Yes. And then if that was not enough for you, they're going to have a Block 3, which is actually going to be significantly bigger than Block 2 as well. So, yeah.
So we'll talk again next year.
Yeah.
Yeah, well, we'll be talking.
The rate at which these guys are going?
Yeah.
Yeah, next All Space Considered.
Yeah, we'll have to
Next
see.
month.
That's
That's right,
next
next
month.
month.
Be back
Yeah,
here.
and they have said aspirationally they would like to do up to 20 in next year, but I
Yeah.
think that is very much aspirations.
Well,
but if they can do it, man, hats off to you. That's like that's a lot of sleep lost.
I do know that NASA lit the fire under them to get this moving. 'Cause
Yes.
this Artemis relies on this at this
Yes.
point. For us to get to the
does.
moon,
Yes, it
this
does.
is how we're getting there.
And
So,
eventually, this booster is going to have to be human rated.
yes.
And all these tests you do, you need a lot of testing before you put a
put a
human
human.
being on board that vehicle.
Yeah.
Absolutely.
And we're really looking forward to that Flight 7 from Starship Super Heavy, and there should be some really cool footage. I just read from one of the FAA licensings that they're actually going to have NASA's Gulfstream jet that they use for infrared imaging out there. They're actually going to image Starship as it is in re-entry coming over the horizon and to landing. And in order to do that, they have to turn all of the lights off on the Gulfstream in order to do that, and that includes their navigation lights as well.
Right.
So they're having to get special permission from the FAA and also Australia's governing body in order to do that. Basically, they are going to clear out the airspace there to make sure nobody runs into NASA's own jet, not just the rocket. that's gonna be
or the
careening
400-foot long booster.
Yeah,
That's
that's going to be astounding. I can't wait to see that footage.
Well, thank
Yeah.
you so much for that
you.
out to launch today. Thank you, Jared.
Thank you.
Well, folks, as you know, here at Griffith Observatory, we have an exhibit called Other Worlds, Other Stars. And our exhibit, that was created, just about 20 years now. 20 years ago.
Yeah, it was 20 years.
20 years ago. The building reopened in 2006 with this exhibit, and it had 7 buttons to push.
Yep.
And there were a few hundred exoplanets known at the time. Things have changed. Let's take a look at this little video here. And this is the discovery rate. So the first one in 91, 92 was actually around a pulsar.
And then
And here they come.
96.
So a little slow at first, a little slowly. Most of these are being found using the radial velocity method, where the star's wobble is being found. But by the early 2000s, we're really starting to pick up, and right now the building reopens. 170 of them or so.
Then we're going to get Kepler soon. A little patch of sky
Yep.
it's stared at.
Yep, we're going
And
to
I have
launch
to
a
illustrate
spacecraft.
every one of these
There it
things.
goes. Here comes Kepler.
He never leaves.
Yeah, this
Just
is
never
my
leaves.
job.
Right
And
there.
there's Kepler, so that little
Boom.
field of view is Kepler.
Yep.
Yep.
And then
That's
we're going
so
to get
cool.
K2, which is when that
Yep.
little wheel on it broke and they could only aim it at the ecliptic. So that little sine wave is K2. And
Yep.
Oh, so cool.
we're getting to today's
So-
count almost.
This was as of 2022, 5005. Boom.
Yeah.
And that sort of square there, the cross, that was the Kepler mission where it found it. And then, like we said, it lost its ability to point in one direction, and it had to sort of observe along the ecliptic. But the TESS mission is out there now finding exoplanets in all directions. A lot of those were found by ground-based telescopes. Right now we're at something like 5,806. Huge number of exoplanets, and we still kind of only begun to look.
Yeah.
You know, discovering whether they're Neptune-like, gas-like, super-Earth-like. What is super-Earth? What is that? Well, they're ones that are a few times the size of the Earth. You know, more massive, larger. Terrestrial, those are Earth-sized, Mercury-like. And then unknown, we don't know what these things are. They're there, but they're a thing. We don't know. It's
Just
puffy.
there.
It's a cotton candy exoplanet. So there's a lot of weird ones. And I say cotton candy because some of them are actually fluffy.
I was going to say, it's a real term.
It's a real term.
Yeah.
Real
Yeah.
term. Well, is it a science? I mean, there's a lot of terms
It's
out
a
there for all these
friendly
plants.
scientific nickname.
Yes.
So this is the rate at which that the movie we just watched, this is a graph of it. And you can see early on they're trickling in, and then we hit those big data releases for the Kepler telescope, those big spikes. But then we're still plodding along, and the background number we're finding is getting larger and larger. The TESS mission that launched, it has over, I think, 5,000 or 6,000 candidates right now.
Yeah, there are a lot that are confirmed, right, that are waiting to be checked.
Yeah, absolutely, huge numbers. Now, how do these look on a graph? Everybody wants a graph on a chart. What you're looking at here is actually orbital period, how long it takes to go around. That's the year for the object on the x-axis. The y-axis, the vertical, is the mass of the planet in Earth masses. So a 1 on the vertical, those are Earth-sized. Go out to 365. Oh, gee, there's nothing there. So, yeah, that says something. We'll talk more about that later. But this is actually a little bit of, this is from 2024. But there's more going on in here. There's different types of stuff. I mean, Laura May, what are these different transit, radial velocity? Do you want to describe what?
So we've got these different methods of finding exoplanets. And so originally we found them, the first one was found through this pulsar timing, which is, we have a rapidly spinning neutron star, and then we see a slight difference in the timing of this
That's our last
spin.
example, though.
Yes, correct. So
We have
forgive me.
graphics for 'em.
We do have graphics for this. So this is, we are showing here the transit method, which is how we find most of them now. So we're essentially observing a little eclipse, believe it or not, of another planetary system. So we're observing that little planet going right in front of its star, and we measure how much light is coming from that star, and we can tell there's a little bit of a difference in between when that little planet is just in front. So it's that eclipse that we've got, and we can tell a lot of things from also that little eclipse. If it's a V shape, if it's a U shape, we can tell if it's got an atmosphere, things like that. And then we've got, let's see, I think our next one is perhaps radial velocity.
It is.
Yeah, so radial velocity is how we found the first exoplanet around a sun-like star. That was actually found in France. And you can kind of see, so if you're I don't know, is the audience familiar with Doppler shift?
Probably.
So we see a little bit of a difference in the way the light is shifted more towards the blue or towards the red. And we're basically observing a wobble. We're observing a little wobble of a star because we think there's a planet pulling on it, right? So this is how we found a lot of exoplanets before we had transits. That was our first method. And then we've got direct imaging, which was shown earlier. Now direct imaging, all these methods, what's important to know is that they have biases, right? They don't just find every single planet that's there. A transit can only find a planet that's in that line of sight to us, right? And it's usually going to find planets that are very close in because we can't observe these planets for years and years and years. So if you think about the orbital period of, for example, Jupiter around the sun, or even Neptune, right? Lots of time needed to, then we have to reproduce that in order to confirm that it's a planet and that it's going around several times.
Direct imaging like this is hard because that star in the middle has been blocked out. That's what that weird black circle is. The star is under there being blocked out, but those little dots around it, there's 4 of them. Those are planets. Those are exoplanets found around that star. They need to be big enough to reflect the light to be able to gather it. You're not going to see a Mercury-sized one or an Earth-sized one using this method right now.
I once heard an analogy to trying to see an exoplanet around a star is like trying to look at a mote of dust near 1,000 searchlights from 10,000 miles away. Something like that.
Yeah, I mean, it's
ridiculous.
incredible that we can do this. So. Let's see, what's our next
one?
Did I skip one? No, I think we are.
No, this is microlensing now.
Yes.
So microlensing is when one star or a planet passes in front of another, and you get a weird little spike. Now notice when the planet passed in front, you got another little brightening. What was that extra little brightening that happened? Well, the planet bent the light from the background star to our camera. So the star blocked it out at first, then all of a sudden you get this weird peak. So this is real. We use this to find things like black holes floating around out there, and we found exoplanets this way.
Difficult to reproduce, and
Yeah.
a lot of these are found towards the center of the galaxy. So that's one of the ways that we can do it.
You need those background stars.
Yep.
So, and then lastly, this is that pulsar timing you were talking about.
Yeah, so that was how the very first one was found by a Polish astronomer, 1992, first exoplanet. Kind of odd also that it's around, we find a lot of these planets now around pulsars, which is kind of weird.
I know they weren't supposed to be there.
Right.
I
Yeah.
used to read books saying you're never going to have that. They would have vaporized any planet in the system. And it's the first one we find.
I don't think everybody knows what a pulsar is, first of all. So a pulsar is a spinning neutron star. A neutron star is the dead core of a star that exploded. So you have a supernova that goes off, that explodes, gives off more energy than an entire galaxy for a brief period of time, and they're saying the planets nearby survive.
Or,
Okay.
or
reform.
Or
we-
don't. Right.
Or don't. We're not
Right.
sure if there's a
It
a
gets the
cloud
band
of the
back
dust
together.
that was created. Maybe they coalesce, but it's still a lot of interesting theories
Yeah.
Yeah.
to do with that. Now this is an interesting image. You might think this looks like a comet, but it is not. It's actually a planet. You may not have seen it through a telescope, but it is a planet. It is Mercury. And Mercury can actually be observed with what we call its sodium tail. So we can observe this little emission. Keep in mind, Mercury very, very close to the sun, orbits the sun in about 88 days. And so this is a method that we're now using, now that that has been imaged and that we know about this. This can be done to basically find some exoplanets, believe it or not. So I don't have the name of it off the top of my head. Yes, I do. So this was, I forget if I think it's WASP-69b, this one, or it's K222b, but it's basically losing a lot. I know, very
Catchy.
fun names, right? Catchy names in astronomy. So it's losing a lot of gas, so it can look a little like a comet. It's losing about 200,000 tons per second, believe it or not. But so it is losing this gaseous atmosphere very slowly, but these are new methods that we've got to find exoplanets, and we hope that there are many, many more.
Yeah.
And so this, you may be wondering, well, how do we know? Early on, we told you some of them are Earth-like, some of them are more like Neptune, Jupiter.
You need
How
to
do we
know the
this?
density.
Yep. So you need to know the density, and
Right.
all of these methods work in combination with one another,
Yeah.
right? This is why, again, science is team sport. So the radial velocity people will talk to the transit people. So occasionally, if you have a mass and a radius, well, you can determine largely what it might be made of. And so on this plot, we're showing you, we've actually got our own planets in the solar system. Those are the little triangles that you see there. And you can see how they kind of align with, we've got rock and we've got iron. So Mercury is actually very close to that iron line. It's a very metallic planet. And then we've got the Earth a little closer to the rock. And so then we've got a bunch of exoplanets that have been plotted on there, no numbers, not their wacky numbers,
Right.
but in order to see, so that you can see with the mass and the radius kind of where they align. So it's really it's incredible.
Well, this is when you'll hear in the news a water world was found. Well, the density of that one in the upper right of the plot up there that's on that water line, that's the one we're calling a water world. Now, could it have a dense iron core and then a really thin, wispy hydrogen atmosphere that just averages out to water? Yeah, it could, but what are the odds of that? We go with what's simplest, and this planet is probably dominated by water. It's the most likely explanation. So.
Yep. So,
So, Chris, you've done some artwork of these things.
I
So,
have done a few.
yeah,
so
now
useful for you to know
Wait.
what they're made of, right?
My God, the stuff we've been talking about with a lot of these, the uncertainty about details on some of these, we don't know what they're made out of. But everybody wants, they want these sorts of views, right? Here in a pulsar system, imagining what it would be like. And you've got the surface irradiating with the aurora there. Everybody loves it. This planet may ring true for you. But yeah, thank you. And endless variations on themes of planets that we know. This was done for the school program that we have. And yeah, we were trying to illustrate as many possibilities to just
They're stunning.
let the kids dream a bit.
Did you make these recently? Were these in the last couple years?
This would have been about 2 years ago. We did this battery, 1 to 2 years ago.
Yeah, it's wild to be able to think about all these kinds of things. It's exciting because of the possibilities, and it's frustrating because of the mysteries.
Yeah.
You know, and everybody just wants an answer, right? We all want to see it. We want to know exactly what it looks like. And if I show a picture, I've taken a case for saying, oh, blocks of tumbled water ice on this surface, or volcanoes. We just don't know yet.
Yeah.
But
all of
we
this
have to show
is
something.
But it's informed imagination.
That's
you're not
right. Yeah.
imagining
Yeah, it's
worlds.
not-
You're using that graph we had previously of this is a water world, for example,
Precisely.
here.
Yeah.
Or this one is far from its star, so it's going to be frozen. Or this one is close to its star, so it'll be a lava world.
That's right.
So you're able to take those things and then illustrate them for
Hence the possibilities. We are at the point where our imaginations are being piqued by partial answers for thousands and thousands of worlds. And you imagine just knowing one or two things, it would have driven you crazy back in the 1500s getting the first stories about new continents across there. What if you only knew one or two tiny things about some other place? It's so exciting to discover them.
Yeah.
I'm going to be busy for a long time.
Oh, yeah.
Now,
I like it.
Yeah, now this shot, that last video was straight from our school program. In fact, the music you heard was music the kids that experience our online school program get to hear while they watch it and be inspired.
Yeah.
But these are some of the other shots that I pulled in just because they were so gorgeous. I had to show it
That's
off.
in the Proxima Centauri system, Alpha Centauri. And
There's a little special star.
there is. Yeah, got it. The bright star up there in the center we're panning over to see is our sun.
Yeah.
In
that's
its
our sun.
correct constellation of Perseus, there it is.
There it
That's
is.
home,
So
which
if you-
is what a lot of this is about, right?
Yeah.
Is understanding ourselves and our place.
Yeah, absolutely. So the Alpha Centauri system has exoplanets, and if you were on that exoplanet looking back, this is the view you would have. So there are systems out there. In fact,
Yeah, so we are obviously not just looking for single planets, we're looking for multiple systems, right? This is a system called Kepler 90, and this is showing all the different planets to it in comparison. So this is to scale with our own solar system that you're seeing on the other side. So you might notice something kind of odd, that even though this is the only system we've found with 8 planets, and they're all bunched inside the orbit of Earth,
the Earth's orbit,
which is wild to think about. The resonance
mini solar
it's
system.
a mini solar system.
It's incredible.
That's really quite small. So far, this is the only 8-planet system we've found. By the way,
I could go planet hopping.
you go planet hopping.
It's
Exactly.
a frequent flyer
You know,
astronomical
in
unit.
that text, we edited some of de Fontenelle's text out, and he talks about, maybe they're sending pigeons from each other to different planets, because this is the 1600s.
Yeah.
They're not sending emails, right, or texts. But so far, the only 8-planet system, but we do have, so this is to show you the planet size comparison. So we do have 1 or 2 slightly larger planets. And this is to show you that, as mentioned, this is the TRAPPIST-1 system, which we showed earlier. So this is another of those interesting systems. That one has 7 planets. So we know of 2 other systems.
but they're all squished down in there inside Mercury's orbit, all the way down
So
in there.
again, keep in mind these biases that we have. We're a lot more likely to find systems that are all bunched in. It doesn't mean that things out there, all these systems, are going to be so different to ours. We might be very similar to most systems. It's just that we find these more easily through transit. This is a wonderful system. I promised people ducks today, and I want people to know I was not lying. We don't know. They could be ducks, right? There could be planets. They could be ducks. We don't know their composition.
Okay.
I like the duck. I like the duckling with the
Yeah,
rings.
so it's a star. So anyway, this
looks
is how
great.
this is, believe it or not, one of the only illustrations I found of the TOI 1136 system. It's a fairly fresh system. That's why they're represented as little fledglings, right? It's 700 million years old, which brings about a lot of questions, and we're still trying to figure out how many planets it has. We think there was a 7th one potentially confirmed this year.
Wait, where was the study done?
I do
Does that
not.
say UCI?
the pond.
The interstellar
Chick-fil-A
I think that says
University.
UCI, 'cause
I
that's
don't know.
local.
Wow.
Chick-fil-A,
That's local.
that's
We're
right.
gonna contact this
say,
researcher and find out
That's right.
what they were
just
inspired
I
by.
don't think this was.
from
Yeah.
So this
the
was
Honda
not the
Center.
illustration from their paper. I do want to say.
Are you sure?
Well, you know, maybe they wanted. Maybe that's slipped by
let's
nature.
send it to them then if they don't know about this.
Because it's beautiful. I think it's a nice. You know, we got to show diversity out there. You might
all
also.
right, yeah.
Okay, we're getting.
All right.
Everyone knows this image, or most people.
Did we
I
get permission
sure-
for this one?
You know, this one is
Okay, we'll
presented
move on.
in every
There we go.
single exoplanet lecture.
Yeah, it is.
Tatooine, you may have recognized a planet from Star Wars that has 2 suns. And indeed, many of our stars out there are binaries or more systems.
Yeah,
right.
So this is to show you an example of a system that does not so far have planets, maybe does, but
What
to
a
show
bet.
you, right, the configuration of how those stars, it gets really wild in those orbits. Potentially unstable. We don't know for less.
Yeah,
or
those are
more.
going to be unstable. I'll bet.
But surprisingly,
Well,
yeah, we
never
find
say never. Remember
I
all
know,
the
that's
other
right.
things
There's
we
some
thought
weird-
weren't possible.
You need resonances. If they're in
Yeah.
resonances that then allow each other to reinforce what they're doing, it could be fine. But that's really
depending
tough
on
to do
mass
with, this,
and
with
distances.
6 stars.
Yeah.
though. This is
I have the same feeling, but
So, but believe it or not, right now we've
Yeah.
got 232 systems in the database that are with multiple stars.
Yeah.
So that's pretty extraordinary, and you can get different types of orbits. You can get orbits that go around one star of the system, or orbits that we call circumbinary that go around both stars. So it's pretty extraordinary that we find this, and this is to show you a recent one. So this is another TOI 4633c. So there's that little dot is a planet, that little dot towards the center of the screen that goes around one of the planets, and we think potentially it has a Jupiter-sized planet much closer in. You can kind of see that little dot there.
Okay.
It's as of yet to be confirmed that planet, but potentially the other one, or one of them is potentially in a habitable zone, so potentially interesting.
Do they trade exoplanets? You take the kids for the weekend.
You know, there are mechanisms.
There
where you can
are.
actually have, you can
Yeah,
have, well,
there
and
are.
we know there
I know,
are
that's why I say that.
Yeah, exactly.
I've seen it.
The idea of trading a planet between different suns.
It could happen.
It can happen.
I want to know what the day-night cycle is like there, because
Yeah.
as you go between the two, there's like there's like constant day, but then as you pull away, you will have the night again.
Those aliens
That's
are
gotta be-
struggling with their circadian rhythm.
Yeah,
I
it's
tell
a
you.
lot of Red Bull going on down
And
there.
you might be wondering also, so we're talking about planets that have 1 star, 2 stars, 6 stars. How about, as Default now said it, potentially planets without any stars? So there are planets out there. They get lots of different names. They're sometimes called rogue planets, orphan planets, free floating. So you'll often see FFP for free floating planet. And we've discovered about 115 of them so far.
Well, though I would argue some of them are brown dwarfs.
So-
They get some of these have masses of 10 Jupiters,
Yeah.
12 Jupiters. I'm like, that's probably not a planet.
So there's a lot of things to comb through, and they're harder to discover, right? You'll notice we have about 100 of them for those 5,000 exoplanets. Harder to confirm because they don't have a star.
Yeah.
So we can't see them transiting in front of anything. We don't see this little wobble. So very hard to find, often found through microlensing. And this is we already went through this earlier this year, but in one of the All Space Considered episode. But this is a discovery that was made this year through the James Webb Space Telescope of these fascinating planets. So they're in that little section. You might recognize that famous asterism, so part of that constellation of Orion, Orion's belt. Right below it, near the sword in the Orion Nebula, we actually found these incredible Jupiter mass binary objects that we call jumbos. So again, some of them might be brown dwarfs, some of them not. Some of them are a little smaller.
Some
but
are
they're in
smaller than
pairs.
Jupiter, though, and coming in pairs is weird.
Very
that was the
strange.
weird part of it.
Yeah, so we don't know too much about them, but an interesting discovery. And again, you may wonder, well, how about moons?
OPT. Okay, that's
So you may recognize this moon, or rather this image is a shot from a film called Avatar. And this is taken from the moon Pandora. So moons might actually be potentially more habitable than planets. And have we found moons around other planets, around other stars?
So this is another Chris Butler original.
Amazing.
Oh, yes, this is actually Harriet, I remember. 55
Wow.
Cancri, one of those planets. And the reason it was so interesting was that this was one of the planets where it was a Jupiter kind of planet in size, but it looked like it was parked in the habitable zone where it got the right amount of sunshine. So people were debating if we're just lucky, we'll get, you know, Yavin or some moon of a gas giant where people could be until the Death Star shows up, and then well, there's a whole story. But yes, you can possibly have giant moons, much bigger than a moon in our system, that could have its own atmosphere, ocean, all life system. Yeah, it could indeed happen.
Yeah. Now I noticed you left off vegetation and the aliens.
That's intentional on my part. I don't. The minute you show an alien creature of any kind, the whole show's over. They don't care about my planets. They don't care about my moons. They want to see Fluffy, the little alien cat.
That's right.
So,
Critney.
Critney, our beloved
Hi,
Critney
Patrick.
alien creature, yes, from our shows.
So now, have exomoons been found?
So we have not found any. There are a couple candidates, but nothing confirmed.
They argue.
And interesting that you mentioned you could have a very large one, because this is is a real signal that was discovered in 2017, still to be confirmed. Around Kepler 1625b, and so that little dip you're seeing is the potential transit of a moon. But now the orbital period of this planet is close. I think it's 287 days, so it takes a long time to reproduce that transit. And then keep in mind that moon is moving also. So can we see that transit again? And we think potentially this could be a Neptune-sized moon around a Jupiter-sized object. So to be confirmed. And if you're wondering if we found any Earth analogs, I think that's the holy grail that we're looking for.
Not yet. There's some that are a little bigger than Earth.
This is another illustration by Manchu.
Some around stars that aren't the right color, faint red ones that maybe are Earth-ish sized, the habitable zone. But so far, not an Earth-sized planet in the habitable zone around a sun-like star that we say that's an Earth twin. It's close, cousins, kind of close. So there's some candidates out there that are a little bigger, but not quite. Now, Chris, you've illustrated, of course, water worlds before, and we can take a quick look.
Those
at
are the
here.
ones everybody wants. You know,
everybody wants them, and of course, you end up you want the shot like this with the sun-like star in the background,
surfers, boats,
clouds,
That's right.
the water.
Drones,
looks like a nice day down there.
Yep. Although, I mean, it depends on what the atmosphere is like. If the atmosphere is different, you could end up with this nice planet you made with the right ingredients and everything else. You put too much atmosphere on it, it fries.
Yeah. Well, this is what
Venus, right?
Well, exactly. Well, this is what the Webb telescope is starting to pull apart a little bit.
Yeah.
We're able to get spectra of some of these exoplanets and see water vapor in their atmospheres. This is a real spectrum of an exoplanet where they picked up the water vapor. So there's water at this exoplanet. As the exoplanet passes in front of its star, we were able to see in this one, WASP 107b, this is the cotton candy-like planet, that it's fluffy, but one side was a little fluffier than the other, and it has to do with the way it orbits around its star and the interaction with the star and the exoplanet. As the exoplanet passes in front of its star, you can see sort of that glowing atmosphere and how it interacts, and you can pick up things like titanium oxide, the water bands.
A lot of surfers there.
That's
a lot
right.
of surfers there too.
A lot of
Exactly.
sunscreen.
Now there are more. Now it hasn't picked up a lot yet, but there are more candidates coming. The TESS mission, which is a European mission, it's searching in every direction in the sky, is still working. And like I said, there are thousands of candidates. Once they're verified, they'll come online, and there'll be more targets for the Webb telescope to look at that are within, close enough, around the right kind of star. Webb isn't quite big enough to really get the info we need. Nancy Grace Roman, of course, is going to give us more information, and we'll have that telescope to use. The Plato,
another European Space Agency mission, so that'll be launching in 2026, so that's coming up. And this will be looking at the planetary transits and oscillations of stars. And we've also got the Ariel mission. So Ariel mission will be doing the atmospheric remote sensing infrared exoplanet large survey. That will be launching, quite a mouthful, but that will be launching in 2029. And that will be focused on warm and hot planets like super Earths and our gas giants. So it's going to observe about 1,000 planets. So
There's a
lot coming with exoplanets.
There's even more coming. So you may think 5,000, well, where are the rest? Are we running out of exoplanets? The answer is no. Our current technology has done what it can do, but as we build better and better telescopes, better instruments, we can do more and more. So now we want to end tonight's show with a little reading from this Goodnight Exomoon, an astronomical parody. So Laura May has picked out a little passage for us.
The danger is it will put you to sleep.
That's right. Try
Yeah.
not to
It
fall
might.
All
asleep.
the parents in the room know what happens when you
right.
read Goodnight Moon,
So,
or what's supposed to happen.
Yeah.
good night, exomoon. Good night, satellite flying by the moon. Good night, light and the atmospheric balloon. Good night, astronomers. Good night, monitors. Good night, interns. Good night, lanterns. Good night, clocks. And good night, meteor rocks. Good night, telescope. And good night, finderscope. Good night, pen. And good night, micrometer. Good night, nobody. Good night, accelerometer. And good night to the old scientist whispering globular. Good night, stars. Good night, air. Good night, space, science, everywhere.
Oh,
Aww.
I
So-
like that. And now we get to tuck them all in.
Indeed. So thank you so much for joining us. The program, like I said, is brought to you by Griffith Observatory, Department of Recreation and Parks, and the City of Los Angeles. And once again, we thank Griffith Observatory Foundation. So audience that's here at Griffith, remember to hang out with us after the credits. We have a special video just for you. Audience at home, I hope you had a wonderful year. We will see you in January with a whole year that's going to celebrate Griffith Observatory's 90th anniversary. We're kicking off our 90th anniversary year next year. So
Amazing.
thank you again, everybody.
Thank you.
Okay. Thanks a lot, guys.